Good morning, ladies and gentlemen. I'm back with another video. Today we're going to look at graphing exponential functions. I hope you guys still have the notes, the note page I gave you guys. If you don't, check out the PDF that's on that Moto that has the note page on it with all the transformations. And we're really going to be looking at the second line of this, which talks about the x-intercept, domain, and range. And so if you don't have it out, take a few seconds, get it out your bag, out your folder. So let's get ready to get started, okay? Okay, there are steps to graphing exponential functions. Basically, it's 5 steps. First step is to find the x-intercept and the y-intercept. Now remember, back from your earlier days, the x-intercept is the point on the coordinate plane where your graph crosses your x-axis. And the y-intercept is the point on your coordinate plane where the graph crosses the y-axis. Well, to find these, it's real simple. To find your x-intercept, you substitute 0 for y, and then you solve it. To find your y-intercept, you substitute 0 for x, and then you solve it. Once again, to find the x-intercept, you substitute 0 for y, and then you solve. To find your y-intercept, you substitute 0 for x, and then you solve. Second step is to find your asymptote. Well, to find your asymptote is basically, like we talked about on the graph, y equals k. And when you write your asymptote on your paper, you write it as y equals k. So whatever your k value is, and normally the k value is the value at the end of your exponential equation or your logarithmic equation, and it's off there by itself. There's no variable attached to it. It's normally the last number that you will see. After doing that, you want to see if you need any more points, because sometimes you're going to need about 3 or 4 points. And sometimes the x and the y-intercept will give you 1 and 2. You may need a third point or even a fourth point to try to draw your graph, kind of accurately. So what you do is you complete an XY table. Some people call it an input and output table. It's just a table in which you'll be choosing the value for x, and you're plugging in that x value into your exponential equation, and then you'll be solving for y. So after you find your x-intercept, after you find your y-intercept, after you find your asymptote, and after you've gotten the additional points that you need, now you just plot the points on your graph, and then you trace the graph to determine if it's increasing or decreasing. Well, you have to plot the points and trace the graph, and you want to know if it's increasing or decreasing from left to right, because that's going to determine what your end behavior is. And finally, you'll use your domain and the range, and to see if the graph is increasing and decreasing, to find the end behavior for your graph. So let's review these steps one more time. First things first, find the x-intercept and the y-intercept. Once again, to find the x-intercept, substitute 0 for y, and then you solve. To find the y-intercept, you substitute 0 for x, and then you solve. After you find both of your intercepts, then you look for your asymptote. Because remember, once you have your asymptote, and for the purposes of an exponential function, your asymptote is y equals k. So I know I have a horizontal dashed line. And the reason it's a horizontal dashed line is because it's going to tell me where my graph will come close to, but it will never cross. And if you need more points, complete your input-output table or your XY table and get you some more points. Then trace your graph, and then finally look at the domain and the range to determine the end behavior of your exponential function. So now that we have our 5 steps, we're going to go through 3 examples here in this video. If we don't get through all 3 examples, there will be a follow-up video which will finish up anything that we leave off. So let's check out our first example. Y equals 1/2 of x plus 3. Y equals 1/2 x plus 3. So let's take it step by step. First, step 1. Let's find our x and y intercept. So to find the x-intercept, you substitute 0 for y, and then you solve. X-intercept, substitute 0 for y, and then you solve. So, as you see here, I've rewritten the original problem, y equals 1/2 of x plus 3. Now, even though the y is out there by itself, we're still going to follow this pattern. So, the first thing I will do is I will substitute 0 where the y is. So now, my reformed equation is 0 equals 1/2 x plus 3. 0 equals 1/2 x plus 3. So now that I have 0 equals 1/2 x plus 3, now we're going to solve this. So next step is to subtract 3 from both sides. Because we have to do what? We have to isolate the base. Remember, everything builds upon itself. So when you're solving exponential equations, you have to isolate the base by itself. And in this particular problem, we got to subtract 3 from both sides to get that isolated base of 1/2 of x by itself. So when we subtract 3 from both sides, now we're looking at -3 equals 1/2 x. -3 equals 1/2 x. Now, we got to take a moment to remember that exponential functions and logarithms are polar opposites. So if you're trying to eliminate one, you have to use the other. So now we have -3 equals 1/2 x, and we got to eliminate this exponential function. So what? We apply the log base rule. And just as 1/2 is the base of my exponent, now 1/2 is the base of my log. So now we're looking at log 1/2 of -3 equals log 1/2 of 1/2 x. Now on this side, this log 1/2 and this 1/2 will cancel out, just leave us x. But here we have a peculiar predicament on this side, because we have a log with a negative number. And because we have a log with a negative number, that tells me that we can't do a negative log. So since we have a negative log, we don't have an x-intercept for this equation. So let's check out, since we know that we don't have an x-intercept, let's check out the y-intercept. We have our original equation, y equals 1/2 of x plus 3. Y equals 1/2 x plus 3. Now, where this x is, remember, for the y-intercept, we're going to substitute 0. Where the x is, we substitute 0. Now we're looking at y equals 1/2 of raised to the 0 power plus 3. Anything raised to the 0 power is going to be 1. So now we have y equals 1 plus 3. 1 plus 3 gives us 4. So our y-intercept is 0, 4. 0, 4. Now let's walk through this again. Over here for our x-intercept, we started off with our base equation. We substituted in 0 where the y goes. Now, and to isolate our base, we subtract 3 from both sides. Once we subtract 3 from both sides, our reformed equation is -3 equals 1/2 to the x power. To get rid of this exponent, we apply our logarithm form. So now we have log of 1/2, -3 equals log 1/2 to the 1/2 x. We can't take the negative log. Can't take the log of a negative number. so we don't have an x-intercept for this problem. Then we go to our y-intercept. Remember, substitute 0 for x and then solve it. So now, here's our x. Even though it's an exponent, we still do substitution. So when we substituted that for 0, now we have y equals 1/2 0 plus 3. Anything raised to the 0 power is 1. 1 plus 3 gives us 4. So our y-intercept is 0, 4. Now our next step is to find our asymptote. Remember, in our asymptote, y equals k. So y equals 1/2 x plus 3. Here, my value for k is 3. Like I said, the value for k, the k is out here by itself, all right? So since k is 3, and my instructions for my asymptote is y equals k, my asymptote is y equals 3. Now, we got the asymptote. Now let's put together our input-output table. So, what you do for an input-output table is you get your input value, and then you plug it in, and then you solve for an output value. So here we have -1 and I1. I chose -1 and 1 because it's simple numbers. So, I took my -1 and I plugged it into my original equation. So here's where the x is. Now, I substituted -1 in for the x. So now I have y equals 1/2 raised to the -1 power plus 3. So, remember, negative exponent flips whatever it's attached to. So since I have a fraction here with a negative exponent, my 1/2 to the -1 power now becomes 2 to the 1 power, which is 2. So now I have y equals 2 plus 3. 2 plus 3 gives me 5. And so now my first point is -1, 5. We follow the same rules we did here, but now we're just going to choose 1. So here's my original equation. Y equals 1/2 of x plus 3. We plugged in 1 here for x. So now we're looking at y equals 1/2 raised to the 1 power plus 3. Anything raised to the 1 power is 1. So now we have 1/2 plus 3. 1/2 plus 3 is 3.5. So, let's take another look at this input-output table real quick. Like I said here, I chose -1 and 1. I plugged in -1 for x, so now I have y equals 1/2 to the -1 power plus 3. Remember, negative exponent flips what it's attached to, so this 1/2 becomes 2. 2 plus 3 is 5. My first point is -1, 5. Here, I have y equals 1/2 of x. We plugged in 1 for x. Anything raised to the first power is itself, so 1/2 to the first power becomes 1/2. 1/2 plus 3 is 3.5. So my 2 points are -1, 5 and 1, 3.5. Now, here's my coordinate plane. I've already got my graph set up. So now I'm going to plot out my points. So my first point is going to be my y-intercept at 0, 4. That red line right there is my asymptote. So those are my additional points, -1, 5 and 1, 3.5. And there's my graph line. Now, let's look at it again. Y-intercept, 0, 4. Asymptote, y equals 3. Additional points, and my graph line. My domain, all real numbers. My range, k to infinity, so we got 3. And there's my end behavior right there. As you can notice on my end behavior, this comes from my domain, this comes from the range.